All right. So with section 4.5, the reason why I wanted to sort of nest it in between the two halves of 4.6 is I think that sometimes when we learn things, we learn them and then we're expected to remember them like a long time later, right? And so it's not always as fresh as what we need to, as like the moment that we need to know it. And so I really want to think about 4.5 as like ways to help us solve more types of equations. Like they're tools for us to help solve different kinds of equations, okay? And so let's start with a little what we know. All right, so what we know, we have this equation, 2 natural log of x plus 1 equals 10. And if we think about what we talked about right before break, then we might remember that the first thing we need to do is get that natural log by itself. And we could do that by dividing both sides by 2. And so we would get natural log of x plus 1 equals, let's see, 10 divided by 2 is 5. What is the base here for this particular log? Yeah, that's base e, right? So you don't always have to write log base e if you don't want to. You can just know that you have the base is e. You're going to raise it to the value on the other side, and it's going to be equal to the thing that you are logging. And if all we want is an exact answer, the only thing we have to do now is subtract 1, right? So we could say ex equals e to the 5th minus 1. And we would want to make sure we check for extraneous solutions, all right? And I argue that if you do check, that it will in fact work out, all right? So that's what we sort of covered before the break. What we're going to do now is we're going to see if we can figure out how to solve questions like this, okay? And so let me show you how we would solve this, and then we'll sort of go back and unpack why this might be the case, all right? So one thing I might notice here is that unlike the other questions, I have more than one log, and they're happen to be of the same base. However, I do not have a log on this side. So one strategy that we will learn is we're going to be able to rewrite this like this. Where we have x minus 2 is here, and we have x plus 1 is here. And there's an operation that disappeared when I wrote this next line. What is that operation?
The plus
Yeah,
addition.
exactly, that plus sign went away, right? What sort of took the place of the plus sign?
Multiplication.
Yeah, it actually became, this is the luxury of having a tablet, actually became a multiplication, right? What else changed? There's one more thing that changed. Yeah, exactly. There used to be a natural log here and a natural log here, and now there's only a single one, okay? Now, all of this is to say that if we wanted to continue to solve this equation, we could now say log of, let's see, x squared minus x minus 2 equals 2. And then I could rewrite this as e squared equals x squared minus x minus 2. And I could keep going. Okay. That's what we're going to learn how to do when we get back to section 4.6. So how did I magically know that I could do what I did in this first line here? That's what we're going to talk about right now. Okay. So let's do a quick review on something called the product property. We'll talk about the product property for exponents, and then we'll talk about it for logarithms, all right? But this again will be something you can review again in your Desmos activity that is due today, all right? So here's what I mean by product property for exponents. Let's say you had x cubed and you multiplied it by x squared. What do you get?
X to the power of 5.
And how did you get 5? Where did that come from?
I added the exponents, or if you write it out, it would be x times x times x times x times x, which is the same as x to the power of 5.
Good, good, good. Okay. Now, what that means is we can say in general, okay, so let's generalize this. Now we'll put in some letters. Let's say we have x to the capital M times x to the capital N. How could I write that as x to a single power? I would say x to the M plus N. Okay. I think it's important that we recognize here that we can actually go in both directions, okay? And here's what I mean by that. This is all fine and good. But what if I gave you this, x to the 5th? How could you write that as the product of two things, like x to some power times x to a different power? Like what numbers could I fill in the exponents there?
4 and 1.
Yeah, I could do 4 and 1. That would certainly work, right? And if I did that, then really I could say x to the M plus N. Like if I start with a sum, then I could break that down into x to the M times x to the N. All right. I think a lot of times we go in this direction. We're like, oh yeah, if I'm multiplying, I'm going to add them. But it's important that we recognize we could go in the other direction as well. Okay. All right. So it turns out that the product property for logarithms is parallel to this. And in fact, if I take log of 3 and I add log of 5, all right, what do we think we could get if we add those? And I don't mean as a decimal, I mean like as a concept. Good, we could end up with log of 3 times 5. Or we could say that's log 15. Okay. And so here's what I mean when I say that these properties sort of work very similarly. When I had exponents that I added, it meant that I could break it down into the product of two bases to the different exponents. And so over here, same thing, if I have 2 logs added to each other, I can turn those into a single log where I'm multiplying the 2 values there. And so if we were to generalize this, we might say log base b, right? Because the base could be anything, of m plus log base b of n equals log base b of m times n, right? So like in general, if I have 2 logs and they're the same base, and I'm adding them, it could be equal to a single base or single log with that base and the product of those two things. Again, I think it's important for us to consider the other direction. What if I had this log base b of m times n? How could I write that?
Log base b m plus log base bn. Sorry.
You're fine. I love that more than one person wanted to answer. That actually makes my day. Okay. So is it the same thing that I wrote up here? Absolutely. But we just want to remember in our brains that we can go in both directions. And that's going to be part of the choice that we have to make. Okay. So let's try a couple examples. Let's see what happens. In this case, all right, I have a single log of a product. And so do I want to use this first rule in that direction or the second rule in this direction? Call this one orange. Call this one purple. Do we want to use the orange one or the purple one?
Purple, because everything inside is being multiplied.
Yeah, we're actually going to use the purple one here because we have a single log and we're going to want to unpack it into multiple logs. Okay. And now I know that the orange and purple are technically the same. What I'm really speaking about is the direction in which we're going. Okay. And so if we apply this purple rule here, we'll get natural log of A plus natural log of B plus natural log of C. Okay. This thing in the purple, when we move in this direction, the instructions that you'll see will usually be something along the lines of expand the logarithm. Okay, so if you see that word expand, it means you started with one and you better end up with a lot more than one. Okay. All right, what about example 2 over here? We thinking purple or orange direction? Yeah, this one I agree. We've got more than one log. And so the directions that we might see with this would not be expand, but you might, I cannot spell, might see the phrase condense the logarithm. And when we are condensing it, that means our end goal is to have a single log. So what should I write here for our solution for number 2? Good. Log of D times F. Now, what's the base that I'm implying here? Yeah, we're implying base 10, right? Can anyone think of maybe the number one wrong answer that I usually get when someone is applying this property, but incorrectly?
Log parentheses U plus F.
Oh, that's a good one. I didn't think about that one. Yeah, I would say that this, whoa, log of D plus F would be a really great wrong answer, a counter example, right? What other mistakes might folks make? I've seen some folks do this before. They're like, oh, I know I need to multiply. And they've written like log D times log F. All right, so that would be maybe like the second most common one that I've seen that is incorrect, okay? All right, so let's get this all on one page for you before we move on. This is what we call the product property, all right? We're gonna now take a look at something called the quotient property. Talk about it for exponents as well as logarithm, okay? So let's say I had this, x to the 5th. That could have come from x to the, let's see, what two numbers subtract to make 5? Well, it could be 7 minus 2, right? 7 minus 2 is 5. But as soon as I see that minus sign, right, that's another way that we can write that. And so if we were to generalize this, we might say that x to the m minus n equals x to the m over x to the n. And we could use this rule in both directions, right? We could go this way. We have a single x and we turn it into multiple x's. Or we start with multiple x's and we get it back into a single x. All right, so what is the corresponding property for logarithms? Well, it turns out that we could have something like this. Natural log of 20 divided by 3. What are our guesses? How could I write the natural log of 20 divided by 3? Nice, nice, nice. Everywhere we see that division, it turns into a subtraction. That is exactly what happens. And so if we want to generalize this, we could say log base b of m over n equals log base b of m minus log base b of n. If we were to use the same, if we were to use the same colors as last time, we might say that in this direction, we would be condensing. Oops, no, that's the other color. Orange, sorry. This direction would be condensed, right? We're moving more than one log into a single log. Whereas in this direction, we might expect the directions to say expand. Take one log and make it into a bunch of logs, okay? So if we look at examples 3 and 4, we've got one expand, one condense. What's the first one going to be? What's example 3 going to be? Expand or condense?
Expand.
Yeah, that's going to be expand, right? We've only got one. We want to turn it into a bunch of them. And so what are we going to have here for a natural log of a over b? Yeah, natural log a minus natural log b. All right. That means that this second one looks to be a condensed situation. And so if we were to pack this back up into a single log, we would say log of D divided by F. Okay. So quotient property. We've got it for exponents, but we also have a parallel statement for logarithms. All right, let's move on to the third and final property. But really what we're going to be looking at is how do we mix all of these together? Okay. All right. Power property for exponents. We've seen this one actually earlier today. If we had something like this, x to the 3, and then we raise that to the power of 2, what do I do to those exponents? This 3 and the 2.
Multiply them.
Good. 3 times 2. This is really the same as x to the 6th. And if we generalize that, x to the m to the n equals x to the m times n. Right. Parallel statement for logarithms. We actually saw this the other day, and I said, for right now, I just want you to believe me, but here's the actual property. Log, let's do this, of 2 to the 3rd. Okay. What's another way of writing 2 to the 3rd as a product of numbers? Good. Okay. According to the power or the product property that we just learned, how could I expand this?
Log 2 plus log 2 plus log 2.
Perfect. How many of those log 2s we have? Yeah, we've got 1, 2, 3. No, it would be shorter to write that I have 3 of them. 3 log 2. Okay. Why is that important? This 3 is this 3. And I don't know if you remember the other day when I was like, hey, I just want you to take this power. I want you to bring it down to the front as a coefficient. Just trust me on that one. The reason why is because when we're looking at this power, it's actually, we could just write it out a multiple, like however many times we have it. We apply the product property, and then we combine our like terms, and we end up with 3 of them. Okay. Now, if we generalize this, log of m to the power of n, this exponent comes down as a constant, and I could write this as n log m. Okay. So the power just means we're repeating that process however many times. And then when we combine our like terms, we end up with that coefficient in the front. Okay. All right. How would I rewrite example number 5? Nice. I see that power. Go ahead and bring that down to the front. I get 5 natural log A. Wonderful. All right. What about number 6? What could I do with number 6?
You could do log square root of D.
Okay. Give me that step before you get to the square root. I agree with you.
Log D to the power of 1/2.
Nice. Very nice. Okay. So the rule says that we can bring that power or bring the exponent or the coefficient back up to be the power. And that's how we end up with this 1/2 here. We also want to know that being able to convert between these two forms is going to be super important for us in the future. And so any chance we can kind of practice that a little bit, knowing that it's going to come up again, I think would be useful. Right? So this is your power property all on one page. But again, I think each of these alone isn't so bad. It's more when we mix them together, how do we unpack those? Okay. And so what I'd like to do is this. We have examples, let's see, 7, 8, 9, 10, 11, 12. I'd like to pick a few of these examples to do together. Okay, for the sake of time, I'd like to pick a few of these to do together, and then the rest will be ones that you can go ahead and use as extra practice when you're studying for that exam that we have next week. Okay. Now, before we get to the practice though, I know that sometimes it's useful to have a little bit of a strategy walking into solving things, all right? And so when we're thinking about whether we want to condense or expand, I've found that there's sort of an order that is helpful in doing that, okay? In particular, if I want to condense a log expression, like I want to pack it all back in so that I end up with just one log at the end, it's really useful to go power, product, and then quotient. However, if I'm looking to expand, like unpack it, make a lot of logs, I find it helpful to do my product and quotient first, and then do the power part. Okay. Let me just make sure I'm getting the right colors here. We said condense is orange, purple is expand. Okay. So you tell me, example number 7, are we going to do condense or are we going to expand?
Condense.
Yeah, we're going to condense that one. And the clues would be that we have a whole bunch of logs. We want to turn it into a single log. All right, so let's move through our checklist. Are there any powers, any coefficients that we can move back up into the power? And if so, where are they?
The 2 and the third one.
This 2, exactly right.
Yeah, that.
So we're going to take this. We're going to go ahead and we're going to take this and we're going to bump it up to the power. Okay. All right, so I've got log of x minus 2 plus log of x plus 5 minus log of what? What is my last log going to be of? Nice. Exactly. 3 squared gives us 9. Okay. So we've done the power. Now I want you to look for any addition. We're going to turn that into a product. Where do we see that? Those two terms. If I want to use the product property, what is that expression going to look like? We're going to have a single log of x minus 2 times x plus 5. I keep that minus log 9 there. All right. I've done the power, I've done the product. Last step is the quotient. Log of x minus 2 times x plus 5 all over 9. And that, my friends, is the condensed form of our original question. Okay. Let me pause here for a moment. How we feeling on this? Any questions, concerns, clarifications? All right, we've got one good. All right. Let's take a look at example number 8. All right, example number 8. So example number 8, we have a single log. And so to me, that's a clue that I want to expand. All right. So let's see what the rules say about expanding. We're going to look for any products first. Then we're going to look for any quotients. And then we're going to look for any powers. So product, I see a product on the top, x to the 5th, e to the 6th. So I can write that as natural log x to the 5th plus natural log e to the 6th. Okay. These two on the denominator, y squared z to the 7th, I can write as natural log y squared plus natural log z to the 7th. What operation should I use to connect these two? All right, and why are we doing a minus here? I agree with you. Why are we doing a minus?
The division.
Yeah, the division. All right, now, if all I did was do this, my final answer would be incorrect. What did I miss? Almost. Before I get there, there's actually one more thing that I'm missing. Exactly. Let's put these here in green. I have parentheses around the last two terms because they're both in the denominator, right? They are both in the denominator. If I don't have those parentheses, I would be saying I have this one times this one divided by that one, but then times this one. And that's not what the statement says. So we need to be really careful about those parentheses. Anything in that denominator is going to need a set of parentheses around it. Okay. you can go ahead and simplify that more if you like. Distribute that parentheses, that would be okay. Or distribute that subtraction, that would be okay. Right. All right, now I think we're ready for those power rules. The first term is going to be 5 natural log x. The second one is going to be 6 natural log e. What's the third term going to be? Good. 2 natural log y. And what about that last term? Good. 7 natural log z. All right. I would say at this point, we are almost done. Almost done. There's actually one last thing that we can do to simplify here. And it involves getting rid of a term almost. Natural log e. Natural log e is equivalent to 1. Let's make a note over here. Natural log e, well, that's equal to log base e of e. So this is really saying e to what power equals e? Well, that's 1. So I can say that natural log of e is 1. And I can write my answer as 5 natural log x plus 6 minus 2 natural log y minus 7 natural log z. Right. This natural log of e is 1. We're going to add that to our ever-growing list of like important simplification techniques or nice numbers to know. Okay. I know we get sort of a lot of those, and I just want to make sure that we can sort of focus on the ones that are important. Okay. All right. We're going to do example 12 as our final example here, and then we're going to move back into 4.6. Okay. That means that you can use example 9 as some extra practice, example 10 as some extra practice, example 11 as some extra practice. Right. All right. So this one should look similar to the last one that we just did. And we might be thinking, oh, we need to expand here, and that would be accurate. Okay. And so when we're expanding, we want to look for products and quotients first. Okay. And so if we did that, log base 8 of the cube root of x, what would I write after that?
Minus log 8, 64y to the power of 3.
Okay, we could certainly do that. I like that. And we're subtracting because of that division sign. Can I unpack this one even more?
Yeah, you could separate the 64 and the y to the 3.
Okay. And what sign would I put in between those?
A plus sign.
All right, what do we think?
Would you have to put parentheses around those?
You 100% would need to put parentheses there. Okay. Good catch. All right. Powers. Do we have any powers that we can move down as coefficients?
Yeah, you can make log 864 to just 8.
Like this all becomes 8?
Yeah.
That's not true. Give me an intermediate step. How could I rewrite some of this? Yeah, I would say it is equal to 2, but how did we get there?
Like, how did we
Equa-
get
Oh.
log 8 to 64?
Log base 8. Right, 8 is the base here. But log base 8 of 64 is not equal to 8. It is equal to 2. But how do we get that?
It's
Is
because
it-
8 to the power of 2 is 64.
Okay, so 8 squared. Right, so 64. Well, another way we could write that is 8 squared. What can we do with this first term?
You could convert the cube root of x to the 1/3.
Nice. And then we could use that power property to bring that down, right? All right, what about this last term right here? What can I write here?
3 log base 8 y.
And the sign?
It'll be times.
The sign in front of it. Sorry.
Oh, a plus.
Accurate? Not accurate?
You still need the parentheses.
Yeah, we still need those parentheses. If you don't want to write the parentheses, you can just distribute that minus sign and change that to a minus, and that would be okay. All right. So Ian, I noticed that you said that this could be a minus. Absolutely. If you don't want to write the parentheses, minus distributes here, minus distributes here. Okay. All right. We're almost done. This first 1/3, we can bring that down 1/3 log base 8 of x. Minus, if I bring the power down in the second term, it'll be 2 log 8 of 8 minus 3 log 8 of y. Right. But earlier, Matt said that this whole middle term is the same as 2, and I agree with him. How do we get 2 from there? Good. Log base 8 of 8 is 1. And why is that? For the very same reason why natural log of e is 1. Log base 8 of 8 is really saying 8 to what power equals 8? that equals 1. Okay, and so we're able to take this term and not have any logs in it, but just have a number. Okay. All right, so we're going to stop this video here.